All right. Let's put the dividers away so everybody can see. And now we are going to do the last problem in 4.31, 1D. So here's what the picture looks like. Who can remember all those days ago how we find sine, cosine, tangent, cosecant, secant, and cosine? Who remembers the strategy here? Okay.
You make a triangle.
Make a triangle. When I make a triangle straight down, right? Straight down. And since I know that point, I know I'm counting over 4 and up 5. And then I will do the Pythagorean theorem. So 4 squared plus 5 squared equals x squared. 16 and 25 makes 41, but I gotta square root it. So my hypotenuse is the square root of 41. Right? And then I just do it. So here we go. Remember that the 4 is adjacent and the 5 is opposite. Because here's the angle. So sine is 5 over root 41. I'm going to fix that in a minute, but for now, that's what it is. Cosine is 4 over root 41, and tangent's 5/4. Does that look okay to everybody? So now I'll do my flips. Root 41 over 5, root 41 over 4, and 4 this. And now I'll go back and fix what needs fixed, which are these guys. So 5 root 41 over 41. And 4 root 41 over 41. Does that look all right to everybody? Now, that problem was just like all the other ones we've done before, even practicing for the quiz, because it happens to be in quadrant 1. But remember last week we were looking at some of them that were in other quadrants? And what difference did that make if you were in a different quadrant? There's negatives, right? No negatives here, but these problems can have negatives. All right, number 2A. Believe it or not, this is exactly the same question. The only difference is I didn't draw the graph. You have to draw your own graph. So where is the point 2, -2? Where am I going to draw that? Right 2 and down 2. So here's my angle. That's the point 2, -2. So I'm going to do exactly what Kate said to do before. I'm going to draw perpendicular, make a triangle. This side's 2, this side's -2, and now I'll do my Pythagorean theorem again. Do you see how this is exactly the same?
Yeah.
You just have to figure out where to draw it yourself. So, 2 squared plus -2 squared equals x squared. So 4 plus 4. So x is going to be the square root of 8, but. What about the square root of 8? 2 root 2, Nas? We're in our notes on the back of page 34. In our notes on the back of page 34. Yes, 4.3. Now, I have a feeling that we're going to have to do some serious simplifying here, but let's go ahead and let's just get the basics down first. So, this side, this is your angle, always at the origin, right there. So this is opposite and adjacent. So what's the sign? Sign is -2 over 2 root 2. Now that needs cleaned up, but let's stop there for a second. Cosine is the same thing, only it's positive. And tangent is -2 over 2. I know all those can be cleaned up, but good so far? Okay, now I'm going to start flipping things. So I'm going to get 2 root 2 over -2, 2 root 2 over +2, and -2 over 2 again. All right, now these two are obviously -1, so that's easy. Right? These two are also easy because the 2's will cancel. So that's -√2, and this one will be +√2. Now these are a bit more complicated. Still, they're fine, you can do it, I have confidence in you. These 2's will cancel. If they're both outside of a radical, you can cancel them. So then what am I left with if I do that? -1 over √2, which I rationalize and get -√2 over 2. This one will be exactly the same, only it will be positive. We good? Friends? All right, one more just like that, -1, 4. Where am I putting -1, 4?
To the left.
It's gonna be over here, isn't it? -1, 4. Remember, X is sideways, Y is up and down. So -1, 4. All right, find your hypotenuse. What's your hypotenuse? Pythagorean theorem, what'd you get?
17.
Square root of 17. If you just blindly copy that down and you don't understand where it came from, you are in big trouble. You need to know how to do the Pythagorean theorem, 1 squared plus 4 squared. All right, here we go. What's my sign? 4 over root 17. What's my cosine? -1 over root 17. And what is my tangent? 4 over -1 or just -4. Then my reciprocals. And then I need to fix these. So 4 root 17 over 17 and -root 17 over 17. And I think I'll fix this one too. And again, I'm not marking it wrong if you don't fix this. But over 1 is just the number, right? I don't need to put the over 1. All right, you feel okay about that? Good, because now things are going to change. Let's look at the very next problem. You have been given a point, and the point is 0, -2. What is different about this problem?
It doesn't go down by.
We cannot draw a triangle. Remember, the only triangles that are allowed are the butterfly bow tie triangles. And are any of them going through that point?
No.
So you're not gonna be able to draw a triangle. Okay? That happens when your point or your angle is on an axis. Whenever your point is on an axis, you will not draw a triangle. Instead, you will draw a circle through that point. Now I know what you're thinking, oh my gosh, we've never done this before, and you are right, we haven't. But it's very, very easy. If you have your orange sheets handy, you notice that where it says sine theta, you have the opposite over hypotenuse, but you have something else. What do you have for sine theta? Y over R. In order to do opposite over hypotenuse, I need a triangle, right? Gotta have a hypotenuse, gotta have a triangle. If I don't have a triangle, then I use the other definitions, which are called the circular definitions. So y over r, x over r, y over x, whatever they are, those are for circles. And when do I do circles? When my angle is one of these. So it's running it 4 times. Here, 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 and here. Okay? Now how does it work? Well, that point is an x and a y, guys. The point gives me x and y. So x is 0 and y is -2. That's given. R is the radius of this circle. Well, what's the radius of that circle? 2. And remember, your radius is always positive. Your hypotenuse, radius, always positive. So here we go. What's the sign according to your orange sheet? Sign is y over r. Please don't be saying opposite over hypotenuse. You're right. Sine is opposite over hypotenuse, but there's no hypotenuse in that picture. So you can't use that one. You got to use the other one. So sine is y over r, which is -1. Cosine is x over r, which is 0. And tangent is, y over x. Can't do that, so the tangent is undefined. Undefined, you cannot divide by 0. And this is going to happen a lot when you're on your circle. It doesn't happen at all when you're doing a triangle, but it happens a lot with the circles. All right, now we flip them. So what happens when we flip this? Don't we just get -1 again? Uh-oh, what happens when we flip this one? Undefined. And what happens when I flip this one? Now remember, 0 on top is okay. 0 on top is 0. So 0 over something is 0. Something over 0 is undefined. Were you wondering what those other definitions were in there for? What's this y over r stuff? Now you know. Now you know. It's for your circles. All right, let's look at the next one, which is the same kind of thing. Where is our our point this time? Well, I know it's 3, 0, but that puts it right here. Notice it's on an axis. When your point or your angle is on an axis, you must draw your circle. X and Y are right there. X is 3, Y is 0. This is your radius. What's your radius? 3. And now you're ready to go. Just plug them in. So what's sine?
Is radius always the same as your x?
Well, it wasn't the same as your x here, right? Your radius is going to be whatever the radius is. If you came down 2, your radius is going to be 2. What's sine? Sine is y over r. That's 0. 0 on top is 0. Cosine is x over r. That's 1. And tangent is y over x, which is 0. And then I'll flip them. So the cosecant and the cotangent are both going to be undefined. Would you agree with that? Because when I flip, I get that 0 in the bottom. Bless you. All right, are we okay? When do we use our circle? When the point I have is on an axis, right? Otherwise, if the point's out here somewhere, I make my triangle and do SOHCAHTOA. All right, number 3, switching gears again. All right. The answers here are going to be, it's either going to be plus or minus for all of these, okay? Tell the sign. S-I-G-N means plus or minus, positive or negative. These are radian measures. How many degrees are these now? Instead of radians, what would this be in degrees? 9180. Very, very good. If we don't know by now that pi is 180, we are in trouble. We need to know pi is 180. So pi over 2 will be half of that, or 90. Now, we talked about this before, talking about it again now. Oh, I don't need a circle. I don't know what that was for. In mathematics, this is the way we label our angles. 0 starts here, and then we go up and around. So this would be 90 and 180 and 270 and 360. That is different than a compass. A compass is used for one purpose, and that's navigation. All of this is just plain math stuff. We're just playing with numbers here. This is our setup every single time. Unless it's navigation, north, south, east, west, this is the way we set it up. So the problem says, tell me about the sine, cosine, and tangent of an angle that's between 90 and 180. Would you agree that angle would be in here? So I'm gonna go ahead and draw my triangle, my butterfly bow tie triangle, somewhere between 90 and 180. I don't know exactly where, it's just in there somewhere. I have no idea how long these sides are, but I do know that this side is negative and this side is positive, and the hypotenuse is always positive. Remember, this is the origin. If you're gonna be in this quadrant, bless you,
Sorry.
left and up, negative, positive. The angle that I reference is always the one at the origin. So this would be my opposite and this would be my adjacent, if that's my angle. Would everyone agree with that? Now again, I know no numbers, so I'm not gonna get an answer. I just wanna know, is it positive or negative? So let's look at the sign. Sine is opposite over hypotenuse. Positive over positive is positive. Cosine is adjacent over hypotenuse, negative over positive, so that will be negative. And tangent is opposite over adjacent, so that will be negative. And again, that's all I'm doing is, am I positive or negative?
So, do we need to know the, never mind, I'm not gonna ask that.
All right, let's look at the next one. Again, I have no idea about any numbers, I just need to know positive or negative. So here's my setup. And this time, I am between pi and 3 pi over 2. What's pi?
180.
Half of pi is 90, times 3 is 270. So where is this triangle? Between 180 and 270, and remember, it's always a butterfly bow tie, don't draw anything else. Here's your angle. Hypotenuse is always positive. What about these? Negative, negative, because we went left and down. Negative, negative. This is opposite. This is adjacent. Tell me about sign. Negative over positive, it's going to be negative. What about cosine? Negative over positive, so it's also negative? Be careful. What about tangent?
Positive.
Positive, because it's actually negative over negative. Right? Okay. All right. Number 4.
Yes.
All right, here's my setup. This time, I know my angle. They didn't give me boundaries like they did here. They actually gave me the number. It's 152. So can you find 152 in your standard position setup here? I hope you can. Isn't 152 over here? tell me about the sides. Positive or negative? Positive. Positive. Negative. Everybody got that? Now, I don't want all of them, I only want the sign. It says, tell me about the sign of 152. Is it positive or negative? Positive. And why is it positive? Because opposite over hypotenuse is positive over positive. B. Cosine 8 pi over 9. What are you going to do here? You're going to figure out what 8 pi over 9 is. I think it's 160. So isn't 160 also going to be over here in this quadrant?
Yeah.
Isn't 160 also between 90 and 180?
Yeah.
So your sides are going to be the same as they were a minute ago. They haven't changed. But this time, I want cosine. What do you think about cosine? I hear a negative. 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 Why is it negative? Because cosine is adjacent over hypotenuse. Negative over positive. Tangent 300. Okay, can you find 300? Isn't 300 over here?
Yeah.
More than 270, but less than a revolution. All right. What's your thought? Well, what about this side? Positive, negative, positive. What's tangent? Opposite over adjacent. So won't that be negative? Cosecant, 15 pi over 8. Lordy, 15 pi over 8.
337.5.
Cosecant, you say 337.5?
Yeah.
Where is 337.5?
Between 27 and 360.
It's also here. Would you agree? So positive, negative, positive. What's cosecant? Hypotenuse over opposite, because it's the reciprocal of the sine. So hypotenuse over opposite, I'm getting a negative number, are you?
Yeah.
Ooh, here's an interesting one. Cosine negative 200. Any ideas on how I handle a negative?
Does it go reciprocal?
Upside down, upside down. So instead of going up and round, I go down and around. So this is negative 90, negative 180, negative 270. So the quadrants are still 90 degrees, but if you're going up and around, they're positive. If you're going down and around, they are negative. Okay? Now, where's negative 200 then? Quadrant 2?
Does that change the positive?
Nope. Doesn't change anything. If I am in quadrant 2, this is negative, this is positive, and that's positive. Any angle in quadrant 2. No matter how you got there. If you want positive to get there or negative to get there, doesn't matter. If you're in quadrant 2, Your horizontal is negative, and your vertical is positive. I want the cosine. The cosine's gonna be negative. Negative. Let's see if we can get these last two done, or three done. Sine pi over 11, or excuse me, yeah, pi over 11. What is that, the sine of 16 degrees and some? 16 point something? Where's 16 degrees? Is it 16 degrees in quadrant 1? And what do I know about everything in quadrant 1? Positive. If you are in quadrant 1, I don't care if you're a secant, a cotangent, or radian, or degree. I don't care. If you're in quadrant 1, you're positive. Okay? Cotangent 500. Cotangent 500. Oh my goodness. What does that look like? 500. Isn't that more than once around? So I'm gonna go all the way around, which is 360. And then how much more do I have to go? 140 past 360. Would everybody agree with that? So here I am at 360, right back where I started. And now I'm gonna go 140 more. Won't I be over here? Quadrant 2. Positive, positive, negative in quadrant 2. Cotangent. Adjacent over opposite, which will be negative. All right, you do the last one with your partner. Let's see if you can come up with the secant of negative pi over 7. The secant of negative pi over 7.
Yeah, it's gonna go that way.
But I imagine
If this, you were going to a class, I would have to
No, wrong side, flip the side. Yeah, because it's negative 25, yeah.
All right, tell me about negative pi over 7. Well, where, what is that? Negative pi over 7.
Negative 25.6.
So I hope you put it down here, negative 25. So hopefully you put a positive and a negative and a positive. And then you said, okay, secant is reciprocal of cosine. So it is hypotenuse over adjacent. Did you say positive? If you did, you're correct. My final comment to you today is, I don't know if you noticed this or not, but every time you draw one of these triangles, no matter which quadrant it's in, X goes here and Y goes here, right? If X is negative, cosine will be negative because cosine is X over R. If Y is negative, sine will be negative because sign is y over r. So all that hypotenuse, or I mean, opposite and adjacent is really just x and y. All right, go ahead and gather up and roll in prayer.
I told you this earlier.
Now I got some girls.
I don't.